Hey there, all you cool cats and kittens. This week we're going to be talking about 7-segment displays, wiring our second digit, and counting to 100. So, this week's objectives, we're going to be working on understanding microplexing, multiplexing. We're going to work on wiring up our second digit. We're going to remove the delay from our code because that's ultimately going to screw things up later on. We're going to insert a modified blink without delay code so that we can count from 0 to 99. We're going to serial print that for right now. We're not going to be counting with the digits. And then you're going to email me your activity once you can serial print from 0 through 99 and repeat. So let's first talk about multiplexing. So the definition of multiplexing is a system or signal involving simultaneous transmission of several messages along a single channel of communication. Um, in our case, and this is true for TVs and a lot of different things, a lot of electronics utilize multiplexing. There's not enough inputs on our Arduino to separate or to have two separate 7-segment displays be wired to each of their own individual digital IOs. So because of that, we need to use multiplexing, and multiplexing allows us to share a digital I/O between two components. Okay, we're going to be able to share a single channel of communication and send simultaneous transmission of several messages. Okay, so we're going to be able to send multiple messages along the same digital I/O. Ultimately, we're going to need to switch the common cathode between these two pieces on and off to display each digit separately, but that's going to be done so fast we're not going to be able to see it. So again, this is more stuff that we're going to be getting into next week. This week we're just getting set up for it. So when we go to wire up our second digit, which I'm going to show you guys in more detail here coming up, but this is basically what we're going to be looking for. Okay, to the left, you can see that the wiring I set up for our second digit, all my green wires are the original wires that I had. I've like repositioned them, but they're the original wires that I've had, and they're connecting my first digit, which is my ones digit, directly to the Arduino itself. One thing that I've changed that we're going to talk about shortly here is my common cathode. But other than that, nothing else has changed for the single digit. We'll talk about common cathodes here in a second. The blue wires connect the pins from one 7-segment display to the other. Okay, so they're going to connect my singles digit, my ones digit, to my tens digit. Okay, the blue wires connect that. So you can see that like this first pin, if you look closely, and again, I'll show this to you before, that's connecting to the first pin over here. The second pin comes out and it connects to the second pin. This is what, like the fourth pin over, it comes to the fourth pin. Okay, so all I'm doing is just duplicating where these are connected to. Okay, when we look at the bottom, the second pin over is connected to the second pin over. All right, so I've traced those out. Then the common cathodes are connected with ground wires because a common cathode is a common ground. So I'm using black wires to connect these up. Instead of just connecting this directly to ground at this point, I'm going to connect these to their own separate digital IOs. This is going to be part of the multiplexing. This is how we're going to be able to turn each common cathode on and off to display each digit separately. So my first digit comes across and it comes down, it goes into this 220 ohm resistor, it comes across the gap, okay, so it separates one side from the other side. 220 is just limiting the amount of current going to, in this case, this digit. And then that gets wired up, and in my case, I'm wiring my ones digit to pin 9, and I'm wiring my tens digit, my tens digit to pin 10. Okay, so again, here's my common cathode. It comes out, and before I had my common cathodes wired from the bottom, but there's also common cathodes on the top that I can utilize. So I'm going to leave it at that there. We'll get into that here in a second. So let's talk about wiring first. All right, so let's start getting this thing set up. And I've just taken my old 7-segment display, which honestly, the thing that I would probably recommend you guys do Here, let me go back for a second. I just keep making copies of these things. Okay, so when I go into my Tinkercad stuff, when I'm looking at my 7-segment display and this thing's working, you guys have already turned this into me. If I click up here, I can say duplicate. All right, and that's going to make a copy of this, and this is now where I can start editing and moving on without screwing up what I've already done. All right, so the first thing that I want to do is I need to get a new second 7-segment display in here. So I'm just going to highlight. I could either like drag a new one in here, 7 segments. I can drag it in, okay? Or I can just take this, Control C, Control V, and I can paste it in here. If you do grab from in here, make sure you change to a common cathode, okay? Just make sure you change to a common cathode. So for this here, I'm going to change this digit to be what's called my tens digit. This is my singles digit, my ones digit. I don't really think that that just makes things a little bit easier to remember. And the next thing I want to do is I just want to start really working on cleaning up my wiring from this first so I have enough space to work later on. So one of the things that I've been taking care of here is just sliding these to the side, and I'm gonna edit this a little bit more here, but okay. Okay, and so what I'm doing here is just going through cleaning this up. Now, like for this one here, I need to add at least one more segment. I'm probably going to add a couple segments to each of these, but to add a segment onto these lines, just double click on the wire. Now you can add like a new place to grab it from. So I'm going to double click on my wire, bring it up to like here. That'll be fine, all right? And then I've also been adding like another segment to my wire just to try and clean these up a little bit more. Okay, the other thing that I'm going to do is I'm going to get rid of this, or I'm just going to move that resistor for right now. Okay, I don't need my common cathode stuff at this point. So set that up. All right, just did a little bit more work here off the camera, and again, I'm just trying to make this thing as easy to understand and as clear as possible. So one thing I haven't changed, again, the only thing I've removed is this resistor from up here. All my other wires are going to exactly the same place where they belong. So that's something that you guys want to start with also. So we start to go connect up the next wires. Again, you're just going to match one digit to the next, okay? So like if I bring this, and I'm going to be careful not to connect to, any of my other like segments, okay? So I'm going to start here, and I'm going to come off of my board. I'm going to come across. I'm going to come down to here. Okay, so again, pin B is connected to pin B. And I'm going to change this to be blue to match the rest of my wiring. I'm going to connect from here. Again, that's my next pin, which is A. So A is going to connect to A. And I need to go through and wire each one of these. I'm going to skip my common. Okay, we're going to come back to the common. Okay. And that's pretty good. Now, once I've created these, like I can come back through again and clean them up by just like grabbing the wires, bringing them down, edit kind of like how this thing's set up. Sure. Okay, I need to do the same thing down here in the bottom. So again, I'm going to go from C to C. I'm going to change this to be blue. I'm going to do the rest of these off camera. Okay, so there's all my wires connecting from digit 1 to digit 2. All right, and I would definitely recommend color coding to some degree at least. You don't have to use blue and green, but you should be using 2 different wires to connect those up. Now we need to connect up our common cathodes. Okay, so again, common cathode is a common ground. In order to keep our LEDs from blowing, we need to put a resistor in series. So I'm just dropping 2 resistors in. I'm going to put them over the trough here so that this side of the resistor is not connected to this side of the resistor. Okay, that's going to be pretty key for us. So why I'm like going from the top down. When I go to connect this up, I need to grab my common leads, okay? And again, whether you use the common above or use this common down here, it really doesn't matter. Like it's the same connection electrically. I'm just gonna run a wire over here, that one, and I'm gonna run another wire over here for that one. And both these are gonna be black because ultimately they are ground wires, even though they're gonna go to a digital I/O. Okay, and now when I come into and I go to wire between here and pin 9 and pin 10. Okay, so this is going to allow us to control our common cathode. Like for instance, if I had pin 10 on high and pin 9 on low, pin 9 would be my grounds, and any information that I sent to both of these digits, it would be able to pass through digit 1 because the high coming out of our pin would be able to transmit through the low in pin 9. It can't pass through the high in pin 10 though, because I just displayed this digit here. Then in the next moment in time, we can turn 10 to low and 9 to high. And now we can display information on pin or on digit 2, which is our tens digit, and make that allow information to pass through, while digit 1 wouldn't because it would be high on both sides. All right, this allows us to, this right here, and controlling this is what multiplexing is. We're going to turn on this common leg or turn off the common leg so that we can display one digit in each. And ultimately, we're going to flip between these 2 digits so fast we're not going to see the difference. They're just going to appear like they're both on at the same time. But the reality is only one of these is on at one time, and then the next one is on at the next split second later. This is the way that all clocks work. This is the way that your televisions work. If you notice when you take pictures of TVs, they look squiggly. It's because of the multiplexing and the fact that only a certain portion of your TV is displaying information at any one time. So this is a pretty common process to happen here. All right. I'm going to switch through to my other wiring, which looks a little cleaner here, and then we're going to start talking about getting rid of the delays and counting. All right, so here we are in my new wiring. Okay, and I'm looking at my code. This is the same code that we ended with at the end of last week that you turned into me. Currently, if I start my simulation, I'm doing nothing. Oh, because I've moved these wires. Okay, so technically I should be counting from 0 through 9 and back again, but I've changed these. So we need to edit and add these common cathodes here. So first of all, in our integers, right? So these are constant integers. These are things that aren't changing. These aren't going to change either, okay? So these are also going to be constant integers. Both these lay out my common cathodes for my LEDs. The first constant integers, I'm naming ones as in like the ones place, and that's in pin 9. Then I'm creating a new constant integer named the tens place, which is going into pin 10, okay? And that's just by chance that tens and 10 are the same. It doesn't really matter that much. we're going to need to define that so that we can control what digit we're working with. And the reality is here is that we need to set pin modes for both those as well. And they're going to be outputs, okay? So when we come in here, we're going to say that ones is an output and tens is an output, okay? And so this is going to set common cathode for ones digit to output. Okay, and I'm going to come through to here. This is going to set my common cathode for my tens digit. Okay, so if I go again to start the simulation, nothing's going to happen. Oh, no, they both happen. Okay, because they're right now, they are both being written to low. So I'm just going to do this real quick. Digital write ones high. Digital write tens high. Okay, so that's turning both of these pins on. It's going to turn both these pins on. Okay, so again, we're displaying 5 volts worth of power on this side, and we're also pushing 5 volts of power on this side. So because we have 5 minus 5, that's a 0 volt potential difference. Nothing can pass across here. So in order to make it pass across, we need to turn one of these to low. All right, so if I were to stop my simulation and say my ones digit, if I were to set ones to be low and tens to be high, now I count in my low digit because again, all the high voltage can pass through to here. When I stop my simulation, if I switch this to low and I set this to high, now I'm counting in this digit instead because now the power can pass through here. It can jump across the blue wires to the second digit, and then it can pass through to pin 10, which is low. Okay, well, pin 9 again is high, so power can't pass through because there's 0 potential difference. If I set both of my digits to high, then both will display the information. I'm sorry, no. If I set both of my digits to low, excuse me, if I set both of my digits to low, then they will both display the information. But that's only good if we want both digits to display exactly the same thing. Okay, so if we wanted it to display 0 or 11 or 22 or something like that works. But if we wanted to display a number like 21 or 37 and we have two separate numbers, this doesn't work. Okay, so that's what we're going to be working towards later on. In the next video, we're going to talk about adding, getting rid of the delays and counting. All right, so once you're done with this and you get this thing to count basically like this, you should be able to switch between high and low here. You should get just one of these to be turning on at a time. Once you can get that to count from 0 to 10, then you're ready for the next lesson. You don't need to send me your code at this point. Send me your code at the end. Once you can both do this and you can serial count from 0 to 99 and back again. All right, so if you're successful at this point here, great, move on to the next video. If you're not quite ready yet, then finish that up before you move along. And again, to go back to this thing here, to determine what digit is displaying the contents, we can set one common cathode to high while the other is low. This is what I was just doing. Whichever common cathode is set to low, that digit will either be, or whichever digit is set to low, that digit will be on while the other is off. Okay, both digits cannot display different information at the same time. Rather, one's going to be on while the other is off, and then it's going to switch. Okay, that part of the process, though, we're going to go through next week. All right, so the next thing we're going to talk about here is removing delay from the code. Good luck. Email me if you have any questions, all right?